Kirchoff's loop rule says that the potential difference when you travel in a complete loop around a circuit must be zero. This means that if you move from point A to point B to point C to point D and back to point A, you must have no change in potential. Now, in order to use this information, we'll need to define some loops. Now, looking at this circuit diagram, I can see three possible loops. A first one here, a second one here, and a third one all the way around. Now, because I'm interested in potential around these loops, I want to keep in mind my equations for potential relating to resistors and capacitors. Let's look at loop 1. If I start at position B and move all the way around the loop back to position B, I need the potential difference to be 0. As I move across resistor 2 in the direction of the current I've defined, I'll be losing electric potential, so the potential difference is just negative I2 R2. As I move around the loop further and get to resistor 3, my potential is going to increase because my current is against the direction of the loop, so I add I3 R3. Now, because I've arrived back at point B, Kirchoff's rule says that these two things must add up to 0. You could try the same thing with loops 2 and 3 to make sure to understand the signs of terms. Now, interestingly, you don't need every loop. In fact, if there are 5 loops, you only need to describe 4. If you have 3, you only need to describe 2. As long as all of your loops together describe each element in the system, you don't need any more loops.